Welcome to section 3.3, derivatives of products and quotients. Our goal today is to find the first derivative of functions that are written as products or quotients. So we'll be going over two new rules for finding derivatives today. Our first one is product rule. So if we see that our function is two different functions multiplying, so a product, and our derivatives exist of these two functions, then the derivative is going to be the first times the derivative of the second plus the second times the derivative of the first. We'll go through some examples so that way you can see it in action, but once you get the hang of it, it comes pretty easily. Our quotient rule is if we see two functions as a quotient, and if they both of our derivatives exist, and the denominator, of course, is not zero, then to take the derivative, we would take the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So let's get started. Find the first derivative and simplify. So here we can see they are a product. Our first function, we'll label f of x, is 7x to the 6th. And just so that way we know, our derivative is going to be 7 times 6x to the 5th. And that is 6 times 7 is 42x to the 5th. Okay. Our second function is 3x cubed plus 14x minus 10. And the derivative of our second function is 9x squared plus 14. So remember, to take the derivative, f prime, we take the first times the derivative of the second plus the second times the derivative of the first. And you won't have to write this out every time, but since we are learning it, I'm writing it out. So our derivative is going to be our first, 7x to the 6th, times the derivative of the second, 9x squared plus 14, plus the second, 3x cubed plus 14x minus 10, times the derivative of the first, 42x to the 5th. Now if we distribute, we have one here and we have one here. We may be able to combine like terms. So we have 63x to the 8th plus 98x to the 6th plus 126x to the 8th plus 588x to the 6th minus 420x to the 5th. And so, combining our like terms, our derivative is 189x to the 8th plus 686x to the 6th minus 420x to the 5th. F of x equals 4x squared plus 7 times 2x squared minus 9. Again, we have a product. So our derivative is going to be the first 4x squared plus 7 times the derivative of the second, So 2x squared becomes 4x. 9 is 0. Plus the second, 2x squared minus 9, times the derivative of the first. So 8x and 7 becomes 0. Now we can distribute here and here. So we'll get 16x cubed plus 28x plus 16x cubed minus 72x. Combining our like terms will give us 32x cubed minus 44x. Let's look at a quotient now. Here we are going to use the top, which is 17x, and the bottom, which is 5x squared plus 13. And our derivative of the top is 17, and our derivative of the bottom is 10x. Now, using our quotient rule, we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So what this will give us is the bottom 5x squared plus 13 times the derivative of the top, 17, minus the top, 17x, times the derivative of the bottom, 10x, all over the bottom squared, 5x squared plus 13 squared. This is going to give us, after we distribute and multiply, we will have 85x squared plus 221 minus 170x squared over 5x squared plus 13 squared. And combining our like terms, our derivative will be negative 85x squared plus 221 over 5x squared plus 13 all squared. Two x minus 5 over 3x squared plus 5 is our function. Again, we have a quotient, so we'll use our quotient rule. Our derivative of a quotient is the bottom, 3x squared plus 5, times the derivative of the top, 2, minus the top, 2x minus 5, times the derivative of the bottom, 6x, all over the bottom squared, 3x squared plus 5 squared. We can distribute. We'll get 6x squared plus 10 minus 12x squared plus 30, 30x actually, over 3x squared plus 5 squared. And combining our like terms, our derivative will be negative 6x squared plus 30x plus 10 over 3x squared plus 5 squared. F of x equals 7e to the x times 7 natural log of x. Here we're back to using a product. So we'll use our product rule. So our derivative is going to be the first 7e to the x times the derivative of the second plus the second 7 natural log of x times the derivative of the first. Here we'll have 7e to the x. We'll pull the constant out front. The derivative of natural log of x is 1 over x plus 7 natural log x, and we'll pull that constant out front. Derivative of e to the x is itself e to the x. And so we have 49 e to the x times 1 over x plus 49 natural log of x e to the x. So if I wanted to clean this up a little bit, I would write that my derivative is 49 e to the x over x plus 49 e to the x natural log of x. Y equals 2x cubed minus 5x squared times x squared minus 2x. Again, we have product. Let's use our product rule. Our derivative is the first 2x cubed minus 5x squared times the derivative of the second 2x minus 2 plus the second x squared minus 2x times the derivative of the first 6x squared minus 10x. Now we'll use FOIL to multiply all of these things out. We'll get 4x to the fourth minus 4x cubed minus 10x cubed plus 10x squared plus 6x to the fourth minus 10x cubed minus 12x cubed plus 20x squared. Now combining like terms, we'll get a derivative of 10x to the fourth minus 36x cubed plus 30x squared. X squared minus 3x plus 4 over 4x squared minus 3. Here we have a quotient, so let's use our quotient rule. Our derivative will be the bottom 4x squared minus 3 times the derivative of the top 2x minus 3 minus the top x squared minus 3x plus 4 times the derivative of the bottom 8x. all over the bottom squared. 4x squared minus 3 squared. So we'll use FOIL and distributive property. The top will become 8x cubed minus 12x squared minus 6x plus 9 minus 8x cubed plus 24x squared minus 32x. This is all over 4x squared minus 3 squared. And let's combine like terms. So our derivative becomes 12x squared minus 38x plus 9, all over 4x squared minus 3 squared. F of x equals 7 to the x times log base 5 of x. It's getting more complex, but it's still just a product. So let's use our product rule. F prime is going to be the first times the derivative of the second plus the second times the derivative of the first. So we'll have 7 to the x. The derivative of log base 5 of x is going to be 1 over natural log of 5 times 1 over x plus log base 5 of x, and the derivative of 7 to the x will be 7 to the x natural log of 7. So our derivative, if we clean this up, should give us 7 to the x over x natural log 5 plus 7 to the x natural log 7 log base 5 of x. And if you feel more comfortable, you can put all these in their own parentheses so you know these are a product where one ends and the other begins. That's fine. Okay, f of x equals 8 times the fourth root of x over x squared plus 4. Here we have a quotient, so let's use our quotient rule. Our derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom. All over the bottom squared. So we'll have x squared plus 4. The derivative of x to the fourth root, or 8 times x, fourth root of x. If I pull this one out, I can rewrite it as 8x to the 1/4 using our exponent properties. And that's easier to take the derivative of. So we can use the power rule. We'll have 2x to the negative 3/4 minus, I'll just write it 8x to the 1/4. The derivative of x squared plus 4 is 2x. Okay. Now we will distribute and multiply, which will give us 2x to the 5/4 plus 8x to the -3/4 minus 16x to the 5/4 all over x plus 4 squared. So let's clean this up. Combining our like terms, we'll have -14x to the 5/4 plus 8x to the -3/4 over, oh, I forgot my squared, x squared plus 4 squared. Now we could take it even a step further. You'll just have to see what the homework, how far the homework is asking you to simplify. But we can also take this and simplify it to be, if we take out that negative 3/4 exponent, we'll be left with a 2 times -7 x squared plus 4 over x to the 3/4, because putting that exponent in the denominator will make it positive, and we'll still have x squared plus 4 squared. Again, you'll just have to see how far it's asking you to simplify it. Using those exponent properties is always, always, always a good idea, no matter what. For our final example, we will do a combination. We have a product in the numerator, but altogether it's in a quotient. So we'll have to do both. Let's start with the numerator. We have our product up there, and in order to do our quotient rule, we're going to need to know what the derivative of the top is. So to find the derivative of the top, we will take the first, 2x cubed minus 5, times the derivative of the second. So 3x squared is 6x, plus 1 is 0, plus the second, 3x squared plus 1, times the derivative of the first, 6x. Distributing these out will give us 12x to the 4th minus 30x plus 18x to the 4th plus 6x squared. And so the derivative of the top is going to be 30x to the 4th plus 6x squared minus 30x. And now that we have the derivative of the top, we can do our quotient rule. So, to find the derivative of f, we will need the bottom x squared plus 7 times the derivative of the top, which we found out is 30 x to the 4th plus 6 x squared minus 30x minus the top 2x cubed minus 5 times 3x squared plus 1 times the derivative of the bottom, 2x, all over the bottom squared, x squared plus 7 squared. Okay, let's do a really big FOIL all over. The first term, we will have to FOIL a 2 by 3. In the second term, we'll need to do a FOIL and then multiply it by 2x. This should give us 30x to the 6 plus 210x to the 4th plus 6x to the 4th plus 42x squared minus 30x cubed minus 210x minus 12x to the 6th minus 4x to the 4th plus 30x cubed plus 10x, still over x squared plus 7 squared. Last thing we can do is combine like terms in that numerator. So we will have 18x to the 6th, 212x to the 4th, 42x squared, and minus 200x over x squared plus 7 squared. And that's it for today.